Okay, so I apologize for splitting this up over two videos. My camera had an issue last video. I was just talking away, didn't realize I had to stop filming. So let's go ahead and look at the first example in the notes under empirical formula. So we did some type of analysis and found that a compound is 26.56% potassium, 35.41% chromium, and some percent oxygen. We don't know what this is, but we know there is oxygen present. So we hopefully can pretty easily calculate the percent oxygen in the compound because we know all the percentages have to add up to 100. So I can do 100 minus 26.56 minus 35.41. And you get the percent oxygen is 38.03%. Okay? So let's go through our steps now. The first step was to convert from percentages to grams. So we're going to assume 100 grams like always. So if you want to multiply each of these percentages by 100 grams, you can do 0.2656 times 100 grams and get 26.56 grams. We're just going to go ahead and write it out though. So we have 26.56 grams of potassium. We have 35.41 grams of chromium. And then we have 38.03 grams of oxygen. Okay? So the second step is to go ahead and convert these from grams to moles. So for that we do dimensional analysis. So we drop the grams of potassium down. The molar mass for potassium is 39.10. And that's over moles of potassium. So I'll go ahead and write all these down, then I'll do it all on the calculator at once. Drop grams of chromium down, moles of chromium goes on top. The molar mass for chromium was 52.00. So on my table it says 51.997, so that rounds up to 52.00 and 1 mole of chromium. And there are 16 grams of oxygen and 1 mole of oxygen. Okay? So grams of potassium cancels grams of potassium, grams of chromium, grams of oxygen. So go ahead and type all this in your calculator and get your number of moles for each. Okay, so hopefully there's what you got. Notice I rounded off to correct significant digits. Here, it's important because it's good to build good habits, but our ultimate answer is going to be a chemical formula. So if you don't use proper significant digits here, it might not matter, but if you round off too much, if you just rounded this to say 2 or rounded this to 0.7, you won't get the correct final answer in the end. So I've done the first 2 steps. Now the third step, divide all the number of moles by the smallest number of moles. So look at these 3 number of moles, find the smallest one, and it is 0.6793. Okay, so I divide all these numbers by 0.6793. So obviously 0.6793 divided by itself is equal to 1. At this point we drop off the units of moles, okay, and we're just left with an integer here. Or it could be a decimal number. So here I'll do the same thing, 0.6793. I'll type in the calculator, 0.6810 divided by 0.6793. And I get 1.0025. So I'll just go ahead and write that out, 1.00. So I apologize, it should be 1.0025 there. Just go ahead and write it all out for now. And the last one, I'll do that, 0.6793. So I'm going to cancel off the units here each time. Like I said, 2.377 divided by 0.6793. And I get 3.499. Okay. So now I have to make all these whole numbers. So that can seem like a little bit of a tricky step. So the first one isn't really an issue. The second one, when you have 1.00 something or 2.00 something or 1.999 something, when it's that close, you can use discretion and round that off to 1. Okay, only if the numbers after it are zeros. So you wouldn't round 2.85, for example, but you could round 2.99. Okay, so use a little discretion there. But then here we can't round that. Okay, so you have a little cheat box in your notes, and it starts off with saying 0.25 times 4. Okay, so what that means is if one of these numbers ends in 0.25, multiply all the numbers by 4. If one of the numbers ends in 0.33, multiply them all by 3. So we can multiply all these by any whole number as long as it makes our final answer a whole number. So this rounds to 3.5. 3.499, we can round that up to 3.5 to make the math easier. So I see in my box that 0.5 multiplied by 2. So I multiply all my numbers by 2. So now I get 2, 2, and 7. So now I have all whole numbers. So now I can go back and write my empirical formula. So I have K2, Cr2, O7. So it turns out that molecule is potassium dichromate. So if you get to this point, and I made some judgment calls rounding 1.0025, I rounded 3.499. Those are easy judgment calls to make. If you get to a point here where there's no easy way to round it to make it whole numbers, and there's no easy way to multiply it by 1, 2, 3, or 4 and make it whole numbers, then go back and check your work and make sure you didn't go wrong somewhere. This should be a very simple step to make them whole numbers there. Okay, so let's go ahead and look at the next problem together. It says we have a 20-gram sample that we know contains only calcium and bromine, and we know that 4 grams are calcium. So that means that the rest must be bromine. So we could solve this one a little bit different way, but let's go ahead and stick with the process we learned to make it easier for us in the future. So this is adding one extra step, but let's go ahead and convert these masses to the masses 2% composition so we can stick with the process we already learned. So I have 4 grams of calcium, okay, divided by 20 grams total times 100. Okay. So I see that calcium is 20% of the compound. Okay. So then I could go in and say I can either do 16 divided by 20 because I know that's the mass of bromine in the compound, or I can just go ahead and do 100 minus 20 and then I get 80% bromine. Okay. So now we're back to the way we're used to seeing the problems. We have a compound that's 20% calcium, 80% bromine. What's its percent composition? Okay. So I just used our old process for converting from masses to percent composition here because we have a 20-gram sample and 4 grams of this calcium. So let's go ahead and convert these to grams, which I realize is kind of undoing what I just did, but let's go ahead and assume the 100-gram sample. If you want to assume the 20-gram sample, go ahead and try it on your own. You'll get the same answer here. You can skip the step I just did, but let's go ahead and keep it simple. Keep it like we've always done it and assume the 100-gram sample. If we assume a 100-gram sample, we now have 20 grams of calcium and 80 grams of bromine. So let me go ahead and emphasize the 20-gram sample and the 100-gram sample will have the exact same percent composition. Okay, so percentage isn't affected by the mass there. So I want to convert both of these to moles. So I have grams of calcium, moles of calcium. So I have grams of bromine. I have moles of bromine. Okay. So the molar mass for calcium is 40.08. 1 mole. The molar mass for bromine is 79.90. Okay. So if I do that math, 20 divided by 40.08, I get 0.499 moles of calcium. And I cancel the units there. And for bromine, I have 80 divided by 79.90, and I get 1.001 moles of bromine. And again, significant digits aren't super important here. Just make sure you keep enough decimals enough numbers after the decimal that the numbers are still clearly defined. If you get to the end and realize you can't really make them come out to whole numbers easily, maybe go back and try leaving more numbers after the decimal here. So I have converted to moles. I want to divide each of these by the smallest number of moles. So I have this divided by 0.499. That's of course going to be equal to 1. I have 1.001 divided by 0.499. I get 2.006. Okay. So then my last, sorry I didn't write it out, 0.499. So my last step is to go ahead and make these into whole numbers. So again, I have two options. I can use a judgment call and round off, or I can multiply by 2, 3, 4 and make it a whole number. Here it should be pretty obvious. I can make a judgment call and round 2.006 to 2, and I'll get CaBr2 is my final answer, calcium bromide. If this, for example, had come out to 2.25, then you multiply by 4 or something like that. But when it's that close, go ahead and round it off. Okay? So in this case, we likely recognize, hey, that's actually probably the molecular formula too. But in this case, this empirical formula could also correspond to something like this. Okay? So we know that's likely probably not true, but just be aware, this process doesn't give us the final molecular formula. It gives us the most reduced form of the formula possible. Okay? So we're going to go ahead and stop this video here, and in the next video we'll look at how to convert from empirical formula to molecular formula, which is our ultimate goal because the molecular formula is the actual formula for the molecules.